Hello, my name is Dom Slightem, and this is my prototype for Comp 3015 Games Graphics Pipelines. I have basically made a simple prototype using OpenGL and C++ to implement a program using spotlighting, texturing, Skybox, and 3D model implementation. So I'll run through the code shortly and show you the process of what I did. So this is our main file. This is where we load in our mesh, our textures, our shaders, our skybox, and send all the uniform data to the shaders itself. So here we load in the initial model, compile. So before anything else, we load in our shaders here in the compile method. So we load in our basic vertex, our basic fragment, we link them and use them. And then for Skybox Shader, we do the same. So we have to make sure we compile the shaders and link them to the program itself, or essentially it won't work. So here we basically enable depth test in 3D view. We create our view and projection matrix, and then we send our first set of uniforms to the shader. So these uniforms are used in the spotlight code. So basically this is like the spectacle, the ambient, the diffuse, and like the cutoff angle essentially, but I'll go into that when we actually look into the shader itself. So at the moment we just send our uniform data to the fragment shader. So here we basically load in our textures. So we load in our first texture and second texture. We activate these textures and bind them to the shader itself. If we don't activate and bind these textures, then they won't actually load in. So we can load them here, but we have to make sure we activate and bind them. And we also do them in like texture 1 and texture 0. So we basically make sure we don't overlap essentially. So we have to make sure that this first one is in texture 0 and this first one is in second one, sorry, is in texture 1. Then here it's quite similar, so we basically load in our cube map texture, we activate it and bind it. So now we go through our methods, what I basically run continuously in the program. So here we just rotate the camera y-axis, we clear the color buffer and the depth buffer before anything else. If we do this at the end, then basically nothing will show, so we've got to do this before we load in anything else. Make sure we're using our shader program. We create our spotlight position, our light position, and then we send all these calculations here to the uniforms in the fragment shader. So spot direction, we send our normal matrix, calculate with our light position, and we do the same here for our spot position. So before we load in our model, we have to make sure we set its diffuse, its spectacle, and its ambient, and also its shininess. So here we've got different variables because the ground we're trying to make it not shiny, but the mesh model we're trying to make it shiny. So as you can see, we've got higher variables for here and lower for material shininess. So the lower the variable for material shininess, more shiny it is. We create the model, we set its matrices. So as you can see here, we're doing our calculations to get our model view matrix. So we're sending this data here, and to get the normal we're sending our mat3 version of the MV we've previously calculated here, and to get the MVP we times our MV, so our model view with our projection to make model view projection matrix, and we send it to our shader. So basically leave that here, and then we do the same, but we render the mesh, and then we do the same here for the ground. So we send our data here, create our model, and then basically to make sure our ground is positioned correctly and not halfway through the character, I've translated it so it's below the model itself. I set matrices for the ground, and then we render the ground, and then after everything else we render our skybox. So here this is where we render our skybox. So we start using the Skybox Shader, we create the model, we get the view matrix of the model and we send it here, and then we render the skybox. So this is quite straightforward because the actual skybox code is handled in the shaders itself. So yeah, basically now to go through our shaders, starting off with the vertex one, because the vertex one runs first. This is to get the positions of essentially the textures being loaded in, the models being loaded in, the lights being loaded in. So it gets all the positions of that. and then it sends these positions to the Fragment Shader, what deals with the color and basically essentially making it look pretty. So here we'll talk about the Skybox one. So we're not loading any textures or anything like that, but only getting the position of the skybox. So for example here we got our MVP, what is passed in the set Skybox method. What we do here, so we send the MVP here, and it gets sent to here. So we calculate the vec using the vector position, what we pass in, and this vec here, what's out, is then passed into here, what's in. So that's basically just a simple definition of passing this out, and then that gets passed into here to get the position here. So essentially this is our vector free text color. This is what's passed into a fragment. So we have texture, but the Skybox texture we pass in, and the position we've calculated in the vertex here, and the RGB value of that. And this result comes as text color, what is passed into a frag here. So essentially if we don't pass it into a frag, then nothing will show. Now to go through our vertex shader for everything else, so our texture, our mesh, our lights, just everything except the Skybox really. So here we have our passed in data, our uniform data we pass in through the set matrices here. So all this data we're passing in through this, and then we calculate it with our vertex normal, our vertex position, and our vertex texture called, and we pass it into these positions here. So these are sent over to the Fragment Shader, and then we set the overall GL position with the MVP we passed in times by our vertex position we also pass in. Now to go on to our Fragment Shader, so we've done our calculations here for the position of, well, the position, the normal, the text code. We've done our calculations here, so now we pass it into the fragment. So as you can see, we've in variables here, we've got our frag color, so the overall output, our textures, our uniform structures. So we use light in Blinkfong, but now we're using Spotlight. We don't use the light uniform structure, we just use our material, the Spotlight. So we've got our ambient, our diffuse, our spectacle and shyness, then position, diffuse and spectacle, ambient, direction, cutoff, and so forth. But below is where we do the actual calculations of them itself. So here we've got a Blinkfong model we previously used. So we do that, but we'll actually discuss the Blinkfong spot. So here we create the two textures and combine their RGB values using the mix function. We use the alpha value of the moss texture because essentially the moss texture is the overlay, so we want to make sure that it's just for certain areas of the texture being portrayed onto the first texture and not just the whole image itself, so we use the alpha value as well. So to calculate the overall ambient, we use the spotlight.ambient, the material ambient, and the color we made here. So that gives us the overall ambient, what we use in here. So we make a vector free S and we normalize the spotlight diffuse by the position being passed in from the method called here. So to calculate the spotlight angle, we use the dot method. So the dot method is a GLSL method what calculates the dot product between two vectors. So we calculate the dot product between these vectors here. And then we call this method here, the ACOS, I don't know if I'm saying it right, is also a GLSL method, what basically returns the angle of the value being passed in. So we pass in this value, so we get the angle of that to make angle. We initialize these variables before the calculations itself, and when we go, if angle is below spot cutoff, we use the PAL method of the angle we pass in, and this one here. So the PAL method basically returns the value of the first parameter raised to the power of the second one. So the first power one and the second one, we calculate that to give us the spot scale. Then we use the float s.n to get our max brackets dot. So we use the dot product to return the two vectors, But the max is a GL method that returns the greater value of the two values. So return the greater of the two values. So we do the max of the dot product of this to give us float s.n. So our s is here, and then the n is the normal being passed in. And then the diffuse is the spotlight.diffuse times the material.diffuse, and then the s.m we have made here. So to calculate the spectacle output, so we go if s.n is bigger than 0.0, then we have to do the half value. So we create the vector 3v of minus position.xyz, and then half, so vector 3h equals normalize v at s, so s here, calculate that, and then the spectacle will be the material spectacle times by the pow brackets max brackets dot h comma n, so h is here, then n there, and then material shyness as well. So a lot of GLSL methods being used. So as I explained before, the pow is the return value of the first parameter raised to the power of the second one. The max is return the greater of the two values being passed in, and then the dot product is the calculation of the dot product between the two values being passed in, with its material shyness as well here. So we do a lot of maths calculations here, using a lot of GLSL methods, and then we will return our ambient, add the spot scale, times spotlight.diffuse, times brackets diffuse add spectacle, and then because it's a vector 3 and returning this, when we call the method here, it will return a vector 4 of this here. So this is our program running again. So obviously now you have seen the code, I've explained how it all works together, and there's basically formed this project. So hope you enjoy. The model will be in the link below.